Hello, pre-calc class, that is Kate, Joel, Zach, Victoria, Morgan, and Emily, my mighty six. How are you doing this evening? It's our Wednesday evening lesson, so it's September 9th, and I'll title it in a little bit. I'm not sure what the title is because it has two different topics that aren't the same, so I'll come up with a title at the end. If I remember. And I hope that the flipped classroom is something that will benefit you. You might ask, why would we consider flipping the math class? And the really bottom line answer to that is that you don't really learn math by watching me do it for 45 minutes and then going home and trying to do it. What you really learn math by watching a short time and then doing all the problems for a long time in front of me so I can help you and other students can help each other. So we'll see how that works on this unit. We may not stay flipped for long, but we'll see how it goes. Well, how did class go today? It hasn't happened yet. So far I've only taught you one class. And you guys looked super duper bored. I was getting bored and I love math, so hopefully today was a little more upbeat. Alright, well, more comments on that another time. Alright, our lesson for today is we're going to talk about degrees, so a little bit. Back out of radian land into degree land, where we're a little more familiar. And I want you to be aware that degrees, say we have 45 degrees, that sometimes the degree measure goes a little above 54 degrees, but not quite to 55. So did you know that degrees are broken down into smaller units? And for example, suppose something was measuring 54 and almost to 55. It might be marked like this, and that means 54 degrees and 45 minutes. That each degree is broken into 60 equal parts, and 45 of those 60 parts is marked as a tick mark like that, and it's called minutes. So 54 degrees and 45 minutes. So I might ask you, so you can go ahead and make a note of that, minutes. And so to change that to a decimal representation, instead of degrees and minutes, we can do that by going 54 plus, when we get to the 45, again I mentioned that each one is a 60th. So we have 45 60ths, just like minutes and seconds and hours are broken into 60s, so are degrees. So 54 plus 45 60ths, if you plug that into your calculator, it will come out to be 54, well, this one we wouldn't need to put in our calculator. If you notice, 45 out of 70, out of 60, 45 minutes out of 60 is 3/4 of an hour. 54.75 is the correct decimal representation of 54 degrees and 45 minutes. We can take that a little bit further. What if the measurement was 54 degrees, 45 minutes, but not quite 46 minutes? Then each minute is broken into seconds, and that could be, say, it was 21 seconds. This little mark means seconds. So, if I was going to add this up, I would have 54 plus 45 60ths plus 21 what's? What is the number that would go there to represent the fact that I took a degree, divided that into 60 equal parts, and divided each of those into 60 equal parts? So what part of a degree is a second? So the denominator, see if you can fill it in before I do, is going to be 60 times 60, or 3,600 parts. 3,600ths is the what breaks the the degrees into seconds. So if you plug that is the one that you really do need your calculator for. And it would come out to be, if you put that in, is 54 plus 45 divide 60 plus 21 divide 3,600. You would get 54 point, let's get some action here, camera action, 54.7558 degrees. So that's how you take degrees that are in minutes and seconds and put them into decimal form in degrees only. All right. That comes up from time to time. Used to be, this was a more common way to use measurement in degrees, but I think now this is, but I want you to be aware of both. All right, so that was one topic for tonight. The second one is going to be about arc length. So if I was going to title this, I guess what I'm going to do is go back up here and I would have parts of a degree. That's when we broke a degree down. And now arc length. And the last topic will be area of a sector. So that's a good title for our section. We will call this page 14, and I didn't explain that well. I'll explain that in class, that when you start writing this information, it will be on page 14. If page 13 took you longer than one page, I don't think it did, but if it did, you would call it 13A and B, so everyone will be on page 14 for this. All right, let's look at how to find the arc length. If you're given a circle and you're given an angle, we'll call it theta, and the radius is known, the arc length that I'm interested in is the length that this angle cuts off on the circle from here to here. So if I darken it, you can see that that is the length that I need to know. So there is a relationship. I'll call that S for arc length, and S is often used for arc length. So there is a relationship between S, theta, and R, and that is that S equals R times theta. And this only works if theta is in radians. So sort of a formula for us, and we'll do an example. If it's already in radians, you can just plug and chug, but if it isn't, we have to change it to radians. So we'll do one that's like that. Suppose theta is 240 degrees, so it won't look like this picture. It will look like this. 240 will start here and go, here's 90, 180, 270, so 240 would stop about in here somewhere. So starting here and ending here, 240 degrees. And let's say that the radius that is given in this problem is 4 inches. So I'll draw it on here. So I want to know the length of this. So I'm building a machine, and I need to know how much material to go on here. All right, so let us use our formula. S equals R theta, but we have to change 240 to radians first. So we learned how to do that. 240 degrees times pi radians over 180 degrees. Degrees cancels, so we get 240 in the numerator over 180 in the denominator. That will reduce, the zeros will cancel when we divide both by 10. 24 over 18, I can divide 6 and 6 will give me 4 over 3. So I have a 4 pi over 3 radians. 4 pi over 3 radians. So that's what I'm going to put in my formula. So to find arc length, which I called S equals R, the radius was 4 inches, and 4 pi over 3 is the radian measure. When I multiply that, it's like a 4 over 1 times a 4 pi over 3 means 4 and pi are in the numerator, 3 is in the denominator. So 4 times 4 pi is 16 pi over 3. So that is my answer. If I need to have a clearer idea of what that is, this is inches for, say I have to know this length so I can buy a metal band that is that length. Going and ordering 16 pi over 3 at the metal band shop is probably going to be difficult. So plugging it in the calculator will give us a close estimate. So I won't say it's equal, but when I plug in 16 pi over 3, I get approximately 16.76 inches. So that is the area of what we call the arc length. All right, arc length. Did I call that a sector? It looks like sector, but this is arc length. I'm sorry. Go back, if you wrote sector down, this is arc length. All right, sorry about, I misspoke. All right, coming now is the area of a sector. And that'll be our last concept for tonight. Area of a sector is when we take a circle and say we have an angle. Say we have it's a sprinkler system. And say the sprinkler has a range of 120 degrees. So I'll put it in a standard position. So 120. If we start here, 120 would take the sprinkler about, here's 90, here's 180, so say here's 120. So the sprinkler is going to go 120 degrees like that, and we know that the radius here is 70 feet that the sprinkler will hit all the grass in this area, and I need to know the amount of area that is. So I will use a different way, a different formula for that, because when you have a circle and you know, we'll do the same thing, theta, and you have r, the area this time represented by the striped area is A, and A, theta, and r related in this way. A equals 1/2 r squared times theta when, guess what, theta has to be in radian measure. Alright, as you can see over here, in the example I started for area of a sector, 120 degrees has to be changed to radian measure. When I take out the 10 and the 12 and the 18, it's going to reduce down to, the zeros will cancel, 12 can be divided by 6 2 times, and 18 can be divided by 6 3 times. So I end up with 2/3 pi radians, 2/3 pi. So that's going to go into this formula here when I get to that part. So I have area equals 1/2. The radius was 70 squared, and now we put in 2/3 pi. And so each of these spots